Welcome back, everybody. So today we're going to look at the trapezoidal rule, also known as the trapezoid rule. It's to do with integration, and it's about finding the area or estimating the area beneath the curve. So let's get straight into it. We can have a function. Okay, so this is the pink line here. And what we can do is we can think of a point on the x-axis. Let's just call that A. Think of another point on the x-axis, and we'll call that B. Now what we can do is, if we know the expression for this function, so in the question this will be given to you as f of x is equal to, and let's just say for example something like, I don't know, x cubed plus 2 or something like this. Okay, now we can take the values for a and we can take the values for b and substitute them into this function. This will give us the corresponding y value. So assuming we knew the value for x, we will plug that in and we will get a coordinate for this point here. So it would be a comma something. And when we do the same for b, we'll plug b into the function and we will get another coordinate. So we'll have b comma and then the y value. Now it's the y values that we're quite interested in. So what they basically dictate is that is the height, okay, of the function above the x-axis. Now what we can do is, if we want to estimate the area beneath the curve between a and b, we can think of the shape, the geometrical shape called the trapezium. So if we join those 2 points together, what we're forming here is a shape. So if we just go a little bit out of context here and have a look, a trapezium is a shape that has 2 parallel sides, okay, and 4 sides in total, so these 2 will be parallel, and therefore there's many different shapes for trapezium, like this is also a trapezium, okay, this is also a trapezium, as long as it has 2 parallel sides. But the one that we're interested in is this particular shape here. Okay, so what we can do is we can estimate the area beneath the curve by using the trapezium. Now, those of you who look closely, we can see that this line is actually above the curve. So whenever we figure out this estimate, this is actually going to be a slightly overestimate. But what we can do is we can try to minimize that overestimation by splitting the trapezium into sub-intervals. So many small trapezium would help get the answer as accurate as possible. Now there's also to note that if the curve starts to move into a concave down nature, this is a concave down nature, and we do the same thing, let's say we had another value a and b, okay, and we link those 2 points together, the line is now going to be beneath the axis. So when we estimate this area will actually be slightly lower than the true area beneath the curve. But we'll get onto that a little bit later. So if we move over to the right here, here's one I made earlier. Okay, so we've got a series of what called sub-intervals. So they're all trapezium. This one is like a rectangle, but we can still use the same formula, which is the beauty of it, moving forward. So we have like 1 trapezium, 2, 3, 4, and 5. I say trapezium, you say trapezia, but we have got 5 of these in, we call them 5 sub-intervals. Okay, notice that each time we've marked the x-axis, on the x-axis we've marked the y, okay, and we have joined those up. Now what we really need to do now is we need to know the heights of all of these lines, and so those will be the y values. Remember, we'll plug in the coordinates from the bottom, we'll call them like x1, x2, x3, into the function, and then we'll get the corresponding y values coming out. So let's go down here and have a look at a question. So first of all, the formula for the trapezoidal rule, okay, will be given to you in the formula booklet if you're following the IB syllabus. So you don't need to worry about the formula, and it can look quite daunting. Basically, broken down, like I said, it's a sort of a strain of calculus here. So what we're doing is we're estimating the area between a and b of our function with respect to x. So in other words, we're trying to find the area between 2 points beneath the curve. We're not going to use integral calculus, we're using the trapezoidal rule. That's the difference. So this is the formula, so it's half times h, and then we have this whole string of y values, which can look quite confusing. So what I've done is I have broken this problem down into a little bit more sort of simple terms. Okay, so I'm going to use the laser pointer here, and hopefully you can follow through this process. So h is the width of each trapezium. So when we go back up here, if I wanted h would be this width here between A and B. Going over to this diagram, we would have this is h. This is also h. This is h. Now it's very important that h remains consistent and constant throughout each trapezium, otherwise this rule won't work. So they are all equal widths, okay? Now what can be a little bit confusing as well is if I say h and you think of height. It is the height of the trapezium because it's the width between the two parallel sides. But also, when I referred to this earlier, this is sort of like one side length of the trapezium. So just be a little bit careful there, that h is referring to this sort of equal step between each subinterval, okay? And to find that step interval, what we can do is we can take our lower bound away from our upper bound and divide by how many subintervals. So you'll see that in the example that I go through in just a moment. So coming back to these y values in the formula, what does each one mean? Well, y0 represents the first value of y. So the first sort of value of y that we'll get from our diagram, and yn will be the last value of y. So let's go back to this diagram up here. So what would be yn and what would be y0? This one that I'm circling in purple now will be y0, and this last one here would be known as yn, and that n is correlates with the number of subintervals. But what's important is you see that this is y1, and this is y2, this is y3, this is y4, and this will be y5 then, because we had 5 subintervals. Okay, so those are the numbers, and those will correspond to what you have to put into the formula. So like it said in the formula booklet, this will be given to you, so you don't need to remember it, but this here, okay, can be broken down into these sort of more simple steps. So we have the first y value, the last y value, and now 2, and it's always 2, times all of the remaining y values. So it's very important that in this section here, in this bracket, that you don't put the first y and the last y value, okay, because you have already put those here. So this is all of the other remaining y values. Let's see this in action in a question. So here's a question where all of the values of y have actually been calculated for you. So we're going to start off relatively simple. So this 7 here represents the height. So I shouldn't really use the word height, but it's basically the y values. So it's where it corresponds to on the y-axis, which is 7. It's really the length of this line. And now we have one that is 5. Okay, so 5 would be on the y-axis, and so on. So all these lengths has really been given to you. Okay, so now we have 1, 2, 3, 4, 5, 6 subintervals. So we've got 6 trapezium, all with equal widths. Now we can look on the x-axis to determine what those widths are, and we can see that it goes from 2 to 8. So the width is 6. And we can see it's 6, 6, 6. So the width of that trapezium is 6. Let's put everything into this formula. Right, area is approximately equal to half times the width, which is h, that is 6, remember, open brackets, and then what we do is we substitute in our first y value, which is y0, and what I'll do is I'll circle that in orange, so that's 7, okay, plus the last value of y, which was 13, okay, so we make sure we put that in, 13, then plus 2 times all the other y values. So all the other y values were, now I'll try and use a slightly different color here so it stands out. Let's use red, okay? So all the other y values are 5, 3, 5. So we want to make sure those all go in, 5 plus 3 plus 5, plus 7 plus 9, plus 7 plus 9. And then what we'll do is we'll close the brackets off, but don't forget there were double brackets, so we'll have to close both sets of brackets here. And that is it. Okay, so I just type that into my calculator and I press enter, and I get 234 units squared, which is an area. So that's our first example. Let's move on to example 2. In this example, okay, what we're going to use our calculator this time to generate all of the other values. So in this one, we were given a lot of the information. This one, we're given very little information. So let's go through this question. Use the trapezoidal rule with 4 subintervals to approximate the area between the x-axis and this function from x equals 2 to x equals 4. Okay, so what we'll do, first of all, is let's try and let's sketch this function so we get an idea of exactly what it looks like. So I'm just going to go over to here, and we're going to go graph. Now it's not absolutely necessary that you need to sketch it. You can do most of the question without sketching, but on this tutorial I want to sketch it to show you. So it's 2 over root x, so it's 2 over root x. Okay, so we can go square root x, enter. Okay, so now we have this graph. So what we really want to do is we want to find the area beneath the curve between 2, which is here, and 4, 3, 4, which is here. Let's just move that label out of the way. So between 2 and 4. So the context of the question is basically asking us to find this area here using 4 subintervals. So what we're going to do is we're going to find the height. Now, some of you probably can do this in your head, the subintervals, but I'm going to go through the more thorough process, which is height is equal to b minus a over the number of subintervals, which is 4. So we can see the upper bound in this question is 4. So we got 4 minus the lower bound, which is 2, over the number of subintervals that we want is 4. So that is 2 over 4, which is the same as a half. That means then, when we split this area up into 4 subintervals, what we'll do is we will have 4 trapeziums. So we'll get 1, 2, 3, 4. And that means then what we're going to need to do is get these heights here. So therefore then, if we join these up, we form these trapezium. Okay, so what we have to do is remember that we started at 2 and we go to 4. So, and this value half is quite important because that tells us the width of each one of these trapezium. So we've got a half. So this value is going to be 2.5. The next value is going to be 3. The one after that is going to be 3.5. So if we do a little table here now, what we're going to do is we're going to enter these x values, which are 2, 2.5, 3, 3.5, and 4 into our calculator and find the corresponding y values now. So y equals 2 over root x. And I'm going to show you on your calculator how you can do that quickly. So you might want to do each one individually, just on the calculator screen. That's possible, but there is a way you can do it on the lists and spreadsheets as well. So if we go over to here, I'm just going to create a new or insert a list and spreadsheets. We're going to label this column up as x, and we're going to put our x values down, which is 2, 2.5, 3, 3.5, and 4. And then over here, I'm going to enter y, and then this row here is quite important. This is where we're going to put the function, like the equation of the function. So you hit equals, and then we're going to put the 2 over root x. There we go, enter. Now what that will do is that will hopefully input all these x values, but there is a conflict because the calculator is getting confused whether it wants to put these x values that we entered, which we do, versus like this sort of column reference. So actually you do need to select this arrow here and put variable reference. That's quite important. Press OK, and now it's calculated all those values. So what you need to do now is you basically need to either copy those values down onto a piece of paper, and then we'll enter them into the formula in just a moment, or you can actually press Control C and it will copy that value. Now, I do think that that's a more time-consuming process because you're going to have to flick between a calculator screen and coming back and pressing Control C and then pressing Control V. So what you can do is open up or insert a calculator page, and if you needed to paste that value, you would just, like on a normal computer, you would press Control V, right, and it pastes it. I do think that is quite time consuming. So you choose whether you want to write the values down or just use that Control C, Control V. But I'm going to pause the video one more second here and get all the values put into my expression. Welcome back. I've just typed all of this into my calculator. So the area is half, this is the formula, half times the width of each trapezium, which was a half, so a half times a half. Then we had to put into our formula the y0 and the yn. So if we go back up to the table that created the values, remember y0 is the first value, and yn, which in this case is y4, nothing to do with this 4, it's just that it goes 0, 1, 2, 3, 4, okay, is 1. Right, so just be careful there that you have got the correct y0 and yn, in this case y4, and then it's plus 2 times all the other values. So the other values were these 3 here that I'm indicating with the laser pointer. So it's 1, 2, 3 values, close brackets, press enter, and this is the value you will get. Okay, that is the end. I hope you liked the video, and I'll see you next time. Don't forget to like and subscribe to the channel. When new content drops, you'll be the first to know about it. On the left, click the video for more tutorials. I'll see you next time.